Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, February 14, 2022, Monday, 3:29 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक फरवरी 14, 2022 सोमवार 3:29 सुबह के and presenting to you talk pertinent coordination world. Title of talk is a little different. Quality, projects, works, coordination world, communication network, concrete, civil field engineering and reliable engineers, work contracts, safety, designs, construction methods, claims, etc., as usual, which all are important. And before that, competency levels, I INT-P certificate, that is International Professional Engineer Certificate, then Chartered Engineer Certificate, and then Fellow Membership Certificate. These certificates, purpose of the certificate, show you what is conventional requirement in field of competent engineering. And here is my email ID, that is, here you can say suraj_engineer@yahoo.co.uk. If you are interested to know something or to have a question, kindly send it to this email so that I can read your question and try to respond to you. What is answer? What should be done? And you may accept that or may not accept that. That shall depend on what question is, and my questions shall be responded per experience and not per what people think. Purpose of this talk to have awareness among you people about quality and about coordination work. And this certificate demonstration is only for you to know what happens in engineering world, because across India, Bharat, people are not aware of that. And this is not mandatory, of course. This is, you may say, depends on performance of individual, how far one can reach. These certificates are not obtained just by paying money, but by proving expertise or achievements in field of engineering and life. For example, the certificate, professional engineer certificate at international level, it's no joke. One has to be first degree engineer or bachelor engineer with at least 7 years experience. And out of those 7 years experience, one should have 2 years experience in responsible position. After that, one should appear in examination that is conducted by at international level, Institution of Engineers India, and that examination is, of course, examination, 2 papers are there. You have to qualify those 2 papers. Syllabus of that is indicated, is given on its website www.ieindia.org. It involves engineering subjects as well as non-engineering subjects which come into play in profession. Example is safety, of course it's engineering subjects, quality, what is law related to engineering and law related to workers, and what is society, how do you have to behave towards women, and likewise you can say whatever comes in picture about engineering profession, disputes, or you can see, means it's not one way or other way, it's general. An engineer is supposed to know all this, supposed to act in required way. And first certification is given for 5 years based on what did you achieve in your 7 years, how much did you learn, or how much did you teach. Just in first certification you have to learn actually. You learn through additional knowledge gained through seminars, through webinars, through personal way of how much you act on projects or in designs. What's difference that you had while you passed your engineering and now after 7 years and then further 5 years and 5 years, you can say 7 years, then you have to renew it when you have experience of 12 years total, and again you have to renew it in 17 years. Every 5 years it is to be renewed. So you must not be an old engineer, you must be a current engineer. This means is that level of knowledge you have at degree level or master's level or doctor's level, that should remain there itself. Additional knowledge you should have in terms of either doing yourself, gaining your knowledge, augmenting your levels, or further teach others, teach people, teach engineers, teach all. Advancement of or promotion of engineering is important there, and because engineering never ends, it continues throughout life, and it depends on advancement, promotion, technical change, world change, system change, from calculator world or from log table world or from slide rule world. We have come to supercomputers. And I'm not saying that computers are everything, but computers, we have to draw use of computers. We have to get assistance from computers for purpose of calculations, for purpose of writing, but we cannot use it for original thinking. Artificial thinking is agreed, but original thinking this can't do. We can use these tools, and that's what capacity of engineers should do. It's capacity of engineers that can use computers in professional way. It's not just for typing, but for calculations, for projections, for drawings, for many purposes which others cannot do except engineers. I'm not saying, but use of computer is very important as far as engineer is concerned, and it can save time while processing whatever data. And it's not that data scientist you should be, but you should be intelligent enough, and you can push your job, and you can have many trials on whatever you do. So that certificate tells that into what depth you are. In the same way, competence certificate, another one is chartered engineer certificate, which also is almost same, but only difference is if you are a corporate member of Institution of Engineers India, which is a royal charter body. That charter was granted in 1935. That charter tells that you are a corporate member of this body, corporate statutory body, and therefore you have basic engineering degree and you have required experience, as well as I have been busy, you have been occupied in your profession, or you are finally retired, both. This is kind of a kind of original title which is written in charter itself, that every corporate member, as long as one shall remain corporate member, can use this title, Chartered Engineer India. This means according to rules, according to statutes, according to charters, you are Indian engineer, Bharat Abhyanta, official Bharat Abhyanta at personal level. And here is membership that I have explained to you. I'll close these files currently, and here is, we go to coordination engineering as well as quality engineering, because I have kept combination. Now I am keeping this file combined together. Quality and coordination, that is a part of previous file, and this is coordination engineering. Quality is a life question. One cannot deny quality. And because one cannot deny quality, one cannot deny coordination. Coordination is like a track that speaks, that questions. It's like network, that you have to move within this network, but with logic and with formula, or else nothing. That is what is quality and coordination. And coordination includes communication network, and quality includes work system. Quality is not an isolation, it's widest world of goods and production, manufacturing and construction. Though it's not very expanded world, but its impact is very expanded. Minus quality means rejected product, and plus quality means accepted product. You got my point. If quality is acceptable, product is valuable. If quality is not acceptable, product is not valuable. It is not accepted at level it should be. We have to, particularly engineers have to, they know it and they have to do it. They have to do it. They cannot say no. And people have a right to ensure, to make sure whatever one buys, it should be quality product or you do not buy. That is important. Product should do what it is required to do. Product or good or service or whatsoever you can say, it should perform which it has to do, or else it is not required product. It is not that level product you are looking for, you look for. Product can sleep without quality, that is right, because that is a rejected product. But user cannot sleep due to awareness, and if user is not aware, then user can be deceived by product. That point we should keep in mind. I don't want to say all time, but we have to understand all time that we use materials, artificial materials, production materials, which come directly or indirectly through some natural, original, available products or raw materials, you can say. After due processing, after due designs, after due assemblies of door, whatever you can say, after a comprehensive process, passing through that comprehensive process, these products are delivered in whatever form. And we have to be very serious about that issue. And that's where every day, every time I have become very serious, because I did not find quality existing in this era. It is our country, it's not alone our country. I can say there are many more countries, but because our country is very big, it is having at least 1/6 population of whole world. So we are not ordinary society. We are society that is referred to 16-17% people, means question mark if you don't have quality, if you don't have standards, if you don't believe in that. We have to understand all this. We have to realize all this. We have potential, we have mind, we have capacity, we have all criteria required for system of quality and quality in system. And if these are not obtained, if quality is not obtained, then we don't have any image, we don't have any face, we don't have any reputation. We cannot treat everything, every product in terms of profit, because profit is right of person who sells it or manufactures it, but it should be quality based, again I say. And that is my, you can say, determination to explain everything about that. And quality is not in isolation, it is a part of product. Safety is a part of process. Manufacturing is safety, and safety manufacturing is important, quality manufacturing is important, construction quality is important, and your mental setup quality is important, conduct quality is important, service quality is important. Quality in every walk of life is important. And if you don't have quality, it may not be defined separately, it's a part of personal life. How do we conduct? We may not define that way, but it's also a part of system. Society cannot exist without that system. We have to be clear about that. And as far as profession is concerned, profession means advanced knowledge, and quality is a part of that. If you don't have quality in our behavior, in our conduct, in our work, in our system, in our production, in our industrial products or in our construction product, we cannot name ourselves reliable working society. We cannot name also we are reliable engineers, we are reliable technicians, we are reliable manufacturers. You can say reliability factor counts a lot in engineering designs, in engineering production, in engineering services, wherever engineering is involved. And I can say life is a part of engineering and engineering is a part of life. Without formal naming, life is engineering, it cannot move without engineering. Because every day we do some engineering, we may know that time it's engineering, but it's engineering. Whatever work we are involved with, from manual work to super automatic work, everywhere engineering is involved, and this point we have to understand. And if we can understand that point, we can say that quality is not, it doesn't become a very big issue if we understand what we have to do and if we respect that. And look, quality is not a person, it's not some identity, yet I have to imagine, we have to think it's an identity because it's a part of product, it's a part of our work. We cannot remove it. Even if you remove it, it's not possible to remove it because if you don't have good quality or neutral quality, then you have negative quality, or you can say loss in quality, and this is loss in value of product. Your material goes waste, its use goes waste. Do you accept that? Original value of work is received only when you have quality system and quality work itself, quality product itself. When I say quality system, this means product quality system, I should say, rather than your organization system. Organization system does not have value if quality is not achieved in product, and we have to just change this in our concept. Previously we used to say, okay, quality system works, but quality is not guaranteed. And I say no, quality is required to be guaranteed. If quality cannot be guaranteed, cannot be achieved, then there's no meaning of system. Whatever system do we have, it's all useless. People say, no, we follow each step, we follow whatever defined. Okay, you follow, there should be quality product. Why it's not coming in? Then we have to be shameful about that. Why we have failure? We have failure because we don't have will, we don't have determination. We are not committed, we are not dedicated, and we are not behind that. We don't have focus. We only focus on procedure, and we don't have focus on its character or its, you say, criteria of quality achievement, and it's not difficult as well. I don't think it's difficult, but it's system people don't follow. That's you can say one point. Even if we make system, our own system, or we use another system, or we enter into some system, every person is not, you can say, determined or good follower or good leader there. Every person has some deficiency, but that deficiency should remain to person and not to equipment handling or not to your work design. A problem is that we are not systematic. Systematic means I think hardly few people exist in society who say there is a system, but they don't believe in system. And system means system should be timely, it should be punctual, it should be organized, it should have some regulations, self-regulation, self-imposition, and self-checking. That property is available with very few percent people. Self-control is very difficult. Self-control is very difficult, and this can be achieved only by few professionals and few people. And those who can establish successfully certain system in themselves, and we require such people, we require to establish quality permanently, we have to establish quality system permanently, of course with variations, and we have to establish coordination principles all times on each act. An engineering profession is requiring, and it required in past also. Engineering profession means knowledge profession, mind related profession. Engineering is not just doing work. It has to see basis of whatever it does. Because engineering means all resources are involved. It's not just one resources, very important resources, human resources, that includes engineering staff and engineering workers. Both, both, both categories are very significant because maximum variation lies here in properties, character, capacity, potential of each person can never be equal. It can vary from pass mark to full marks in different ways. But training level equalizes everyone. When training is given to everybody through whatever means, to whatever profiles, one knows what to do. And that profile level, knowing what to do, that is, you can say, establishment of system, and that remains subject to variation, subject to additional knowledge, or subject to scrutiny of whatever we have done, which you can call plan, do, check, and act. That planning, doing, checking, and acting is a continuous process which apply all time. And if we do that, we can continue establishing, continue improving systems, and that is very important. It's not only for quality, but for general life as well. If you say, I make a system every day for myself, I have to get up this time, I have to do this at this time, I have timetable for whole day. I have timetable in my office also for me to do what or whatever timetable fits by others. I have to comply with that. And by chance I deviate myself from that, I feel something that day. Why did I deviate from that? Yeah, if you can deviate due to some other reason, you parallel to something else and replenish loss you got through other item which you missed. Means compensation is already there, doesn't matter. But if you just don't care, deviate something or even just sleep on that, that you can say that time is no use. How many hours you waste there is a question mark. It is a question mark. Why? So system, again I say, it is very difficult, I understand, making system, maintaining your system, working on that system is very difficult. It's not false, it's true. Because you have to control yourself, regulate yourself. Self-regulation is always very difficult because you are a worker, you are a follower, you are a designer, you are a leader. And when you are a leader and follower yourself, you have double responsibility. You have to satisfy yourself, you have to question yourself, you have to beat yourself, you have to punish yourself. Whatever is to be done by you, for you. And that is where you can say best person is who can do all this. Once you are well educated, such as you are an engineer, you are not an ordinary person because you have brain that works, you have got knowledge that can be applied, but that should move further and not to stagnant level, remain there. Knowledge which you achieve, that is wealth you have, because by that knowledge you can get wealth. And it's not wealth of money only, it's wealth of wealth and wealth of wealth. Information wealth, dynamic wealth, useful wealth, reliable wealth, future wealth. So many words can be given, and that's I say quality engineering and coordination engineering. Again I say this approach one should have. And if this approach you have, means working designs become easy for you, manufacturing becomes easy for you, construction procedures you understand and you can do, and we have to do all what is required in that. There is no difference, there is no difficulty. I don't find any difficulty in that. We refer to many other countries, see what's there, how they are working. Why should we worry about that? Can't we do that? My question is that. You enjoy your family, you enjoy your life, you enjoy whatever you want to enjoy. But in your work, you have to be, again I say, determined. When I say serious means you have to abide by your own first. Don't worry what others think of you. First think of yourself. So particularly we are careless society, and I think not only ourselves but many other societies have become careless. And that is because of many reasons, because that we think what shall happen if I don't do, somebody else will do that. That conception comes to mind of everybody. And because it will happen, it will not stop. Why should I worry about that? When I say, why should I worry about that? It's not a good question. You have to worry, even if you are expert, even if you have system, then you have also worry about that. Means why I'm not able to change something here? Am I so weak in mind, or so I don't have any basic information means that I can apply changes? And that really is a question mark. So I can say, particularly for my nation, I can say we have to fix quality, which people are not concerned with. I have not seen many percent people who remain so serious about quality. Maybe it is due to whatever reason, but I'm not interested in reason. Interested in solution of problem. Of course, problems always appear. We don't worry about problems, and we start thinking of problems and resolving problems. I think problems won't appear. It's not question of what you are doing, what you are earning, how much you are making profit. That is secondary. But first is, what is our standard in this country? Are we standard society, or we are loose society? We are fluid society, or we are solid society? We are seriousness, or we are non-serious society? We worry about ourselves, we worry about future, we worry about others, or we do not do anything. These points we have to confer, we have to understand. And after education of engineering, if we cannot do even this much, I can say our education is no use. It is just a futile word of certification and nothing else. If my professor failed to inculcate in me some character like that, or my what we call guru, then that guru has got no meaning. That guru has nothing to do with me, because I just got formal information through that, and not information which should be given to me in some other form. Life is not easy, we know, but life is not that difficult also, if you want to make it easy. Just like our body is a system, works successfully all time from birth to that. And even there's one problem, say in an organ, we feel something. But there are so many problems with many organs in this country, and that is not, in correct light it should be. Our illumination has dimmed. We have dimmed our illumination. Illumination in life, illumination of mind, illumination of knowledge. It should be. But I don't know, we are not caring about that. People have to change mindset, and that is very important if you want to be a lead society in the world. I know there are other nations which claim they are serious, they are quality, but I don't think they are. I can't name here, but there are so many nations which always boost that. They are unequal, but I don't accept that statement. And only way is to standardize yourself, discipline yourself, work in that system, systemize yourself, qualify yourself in world level and not at education level. Education quality is very easy, you can learn, you can do it under guidance of some professor. But your value is added only when you do it in practical world. You do in projects for which you learned, and those who use your service, they should be happy that my professional service is given by very important person, very serious person, and that is we have to achieve. Today no one can be sure about what is done, and it is a fact also that money is spent. I'm not saying money is not spent. but care is not taken. That's only a point. You can walk here and there and see what's happening around. You will not find, shall not find any product to your requirement. Maybe you buy, but you are not happy because you are sure it doesn't give that proficiency it should. So I say we have must surety. What I buy is qualitative. That surety is not available. Even if you buy some branded product or some other product which is expensive, thinking that my expenses are more on this and claims made on online is all right, but it doesn't work. I am very much concerned about coordination issue, about communication issue, because computers have changed entire system. Rather than strengthening that concept, computers have degraded that. Computers have forced you to forget coordination, to forget reliable communication, and to forget your conduct in a working way, in a recorded way. Means everybody moves in its own direction. Nobody cares for where others is going. Others are going. Others are going, and that's really question. Computer has changed our memory system. It has changed our analytical system. It has, of course, changed our, you can say, attacking mind that attacks or mind that receives. It has made us like parrot talk. What I find these days is very important, which I try to reflect that. If I take this generation, current generation, they have very little analytical power, very little. Very little analytical power, very little, you can say, comprehensive power, and they don't try to enter into depth of what should be thought of. They don't have, because they are not able to write properly, they are not able to read books, they are interested in videos and in other communication media. Writing is absent. They are interested only in photographs, or they are interested in selfies. Means only showroom is working, factory is not working. You can say that. And when you don't do something yourself, you don't enter into details, you cannot earn patience, you cannot earn experience. Patience is very important in such life. If you don't have patience, we cannot think. Keeping yourself impatient and trying to think has got no value, because you are interested only in result. You are not interested in procedure. And there is no meaning of result if it is process free. If there is no concern behind that, there is no philosophy, there is no analytical act, there is no electrical value, there is no analytical role. You cannot have peace of mind. And so many factors apply to state of depression one has got in. And depression clearly says that you have deficiency somewhere in your works or in your mind that questions you all time, that I'm not happy. You may have well standards of life, you may have good salary, but again I say, my experience tells me that systems are not available, systems are not working, only systems declaration works, but not system. And that is what we have to cover here. We have to understand fragility degree. We have to understand why this system has become so useless or fragile that if I hammer it, it breaks. And that breakage is very important to understand how to handle it. And that's the only reason I'm not trying to say that everything is bad, but everything is also not good. And that's the important point here. And we have to analyze all this on facts and not on imagination. We have seen many red lines have reached on that path. And red lines means certain stops. we have to wait and cross these stops. And it's not difficult. It's not difficult. First, we have to check our own red lines of mind, our own red lines of not to do something at will, or leave it to others, or not to think of, and that drags us to somewhere not acceptable. And these red lines must go, and this cannot go just by speaking, by doing something, and that is where we have to be very work oriented person. Work doesn't mean only work, and we have to think in some way of, we say coordination engineering, I name it because it's not I'm naming, but for this talk I'm naming it coordination engineering. And you can say this talk itself is a talk of coordination engineering, communication engineering, thinking engineering, and research. Research based on what I did. I try to analyze my experience in past, and I try to compare it with what's happening today and what is we think in future it can take shape off, and that's very important point. And because we all deal with projects every time in life, and many deal with operations which are continuous systems, but projects are not continuous always. Projects can change. Projects start and end. And that is enough, we can say, enough period for a person to know, because there is a start and there is end. And that is, you can say, we can learn a lot from that. And we may say that it's a quality note. It's something that we have to understand clearly. And it's not, just a note. It gives us general information and specific information that we cannot do otherwise. We have. Now I'm talking of engineers and engineering works. We say for reliable quality engineering works deliveries. This is just a page, and you cannot take it otherwise. It's only information, or it's, you can say, collection of my own opinions based on my little experience in career. I'm not claiming what I'm saying is right, but based on my experience, I'm just trying to express what we do, what we think, how we think, what is done, what should be done. It's not that it's end of everything, but because medium is available, I'm trying to do that, trying to share my experience with everybody else. If they are interested, but I'm not sure. People are interested only in results, that's another problem. They're not happy with this. So I am interested in reliable coordination, and that is communication support. For reliable coordination, coordination cannot be affected without communication, and communication means we have to communicate system contents. We have to communicate our question, and we have to find answers and then communicate our answers to a person questions, and then to apply all these. That's also another part, application of system, application of answer. We have to be very serious in that regard. There are some projects I did. For example, this is a school project in Qatar, boys preparatory school. Then there's another one. I'm not going to give details now. There's another one. This was a press complex building, the Al Thawra, located in Baghdad. And this is here, you can say, athlete in Doha. And we can say this is Ruiz plan from Google, and also you can see that here is, this is here a seawater reservoir, you can say. It's reservoir seawater basin for purpose of storing water at industrial plant, circulating this water for cooling purpose. And then it is also, you can say, this is a record building in Qatar for purpose of digital recording of a plant. And here is hospital building in Jeddah, Saudi Arab. And this is a plant at Ras Laffan, Qatar. And that's as you can see. I think that across all this. Now we are on the page where we start coordination engineering, and which is a must, you can say, on every project, without which we cannot even think of doing project. As I already said, coordination is very different word, and we cannot just commonize this. We have to understand this word in its concept itself, not simply what we think itself should be. So here is a point, coordination engineering. Just a minute, please. Let me put off here. What we say about coordination, that's a very big question mark here. What is coordination? I don't understand by that. Means we have to think again and again. What I'm talking of, what is that? Can we understand that clearly? No, it's not easy answer. Coordination, if you think you can, it's fine. We like to coordinate ourselves. Coordination, coordinate. Let us say, I'll try to find what is coordination engineering, we can say. The question is, this is not stone. Let me see what it says. Why coordination is key in construction designs? Here's the page. I try to open this and see how people think about why coordination is key in construction. It says this is a stone mark, and it says something about this. It says most projects require input of several disciplines to produce a complete set of drawings and specifications needed. Erect a building. Architects, civil, structural, mechanical, electrical, and plumbing engineers usually comprise design team, while some complex projects may require other specialists, other specialized disciplines, or consultants. When design teams' efforts are poorly coordinated, drawings of one discipline may not align with that of another. If such errors make it onto construction drawings, there is a chance that building end up with a deficiency or a change order be required to resolve issue. To avoid consequences of this nature, it's imperative that architects and engineers harmonize their efforts and ensure that drawings interface properly. Architectural drawing, floor plans, roof plans, elevations, sections, perspective drawings, structural designs, mechanical, electrical, and plumbing, other disciplines, common coordination issues, how to improve coordination. It's a page. Let me take a printout of this and show to you. So that, of course, we are just taking a public view, what public thinks about this, and that's very important. Otherwise, you can say, I don't know whether I'm able to print this. There's no print command on this. Maybe save image as, copy image, this image. One image in new tab. I don't know how to print out is not coming in this. Well, let me see how it works. There's no printout system in this. Print here. Okay, let me say print is here now. Let's have printed and got it. See, I'm having print commands coming out, and this is from Stern Mark, and I think it should work to understand. Of course, one page, no problem. We can have time for this to know. It's better to explain from people what to think because you're part of people, you're part of society, and I don't impose my thoughts only. I'm just trying to find more and more from people. Is that most projects require input. Most projects require input of several disciplines to produce a complete, you can say, set of drawings and specifications needed. Erect a building, architects, civil, structural, mechanical, electrical, and plumbing engineers usually comprise design team, while some complex projects may require other specialized disciplines or consultants. When design teams' efforts are poorly coordinated, drawings of one discipline may not align with that of another. If such errors make it onto construction drawings, there is a chance the building end up with a deficiency or change order necessary to resolve issue. Avoid consequences of this nature, is imperative that architects and engineers harmonize efforts and ensure that drawings interface properly. Also, we can say applicable codes are important in this case. Design process starts after consultation with client, during which project's budget, expected finish date, visual appearance, spatial requirements, functional program, other design objectives and actors. Having established client's expectations, architect gets work on drawings and specifications. A minimum, a full set of architecture drawings should comprise floor plans, roof plans, elevations, sections, and perspective drawings. Floor plans are vertical orthographic projections which show a building's layout and other physical attributes for each floor. These drawings depict interior walls, doors, windows, appliances, equipment or use of all spaces. Roof plans show top view of building's roof, including slopes, hips, valleys, parapets, skylights, vents, drains, roofing, material, equipment, all other features. Elevations are horizontal projections that show a building's exterior and sometimes interior as seen from side. Sections depict a view of building as though it's been cut along imaginary plane. Perspective view shows a three-dimensional view of building and my projects works basing their work on preliminary architectural drawings. Structural engineers design structure to support buildings that live in environmental loads, thus enabling to remain upright. Generally, a building's structure consists of vertical and horizontal elements such as columns and slabs and connections between them. Among them, structural engineers' job is to tailor these features to fit in architectural designs. Mechanical, electrical, and plumbing MEP designs. Mechanical, electrical, and plumbing systems must also make their way onto drawings before later are issued for permitting and construction. Having access to established structure and architectural layouts, MEP engineers get to work on the respective drawings and specifications. Other disciplines Other disciplines contributing to overall drawing package may include landscape, civil engineers, communications engineers, acoustics and spatially consultants, and otherwise others who involvement may be required, and a clashing arises when drawings don't align well with one another. Common examples of clashing includes columns obstructing views of passes, misaligned slab edges, mechanical ducts running through structural members, and other instances where a disagreement between the disciplines creates an unbuildable scenario. How to improve coordination? That's the point here. Ensure effective integration between disciplines. Right expectations must be laid out before project begins. Architects and engineers must agree on a set of deliverables that facilitate their team's coordination efforts. This may vary from project to project. At a minimum, architects should commit to furnishing engineer with some following critical information: location of slab edges, floor-to-floor heights, cavity depths and ceiling interstitial spaces, parapet locations and heights, and unique architectural features, areas where design is expected to change in future. As structural design moves forward, engineers should in turn share following elements with architect: location, sizes of columns, opportunities for improving efficiency of structure through changes to architectural design. As overall design evolves based on client's feedback, it's important for various disciplines to, to communicate changes these are making so that everyone can stay on the same page. Streamlining exchange of information is an important step in preventing flaws as different parts of design change over time. Today, modern technology offers a great way to improve efficiency of interdisciplinary coordination. Processes such as building improvement modeling, building information modeling, which is usually called BIM, building information modeling, integrate various design inputs, facilitating improving and accuracy of clash detection. Peer reviews are also helpful in identifying systemization flaws and getting them fixed. With aid of BIM, and construction organization practices such as peer reviews, project teams should be well equipped to enhance coordination between design disciplines as well as for complex projects. It always pays to hire a professional construction leader to oversee project's planning phase. So this is just, we may say, what is construction management? Project services, professional construction project management is a super fine-tuned system designed to facilitate planning, coordination, control of a project from early stages always to put close out and completion. All right, that's okay, fine. So we have to close it now and go to something else, and we have to see how does it work. And let us say we go to someone else who I think we got something only from this, not that much. Let's see what research.net says. This is also latest one, I think. I visited this page. I visited already this page, so I don't know why coordination is concerned. Let's say we can say that coordination engineering. Okay, engineering coordination jobs, no. Selection of management, no. Coordination engineering of metal single from, no, it's not that. Engineering coordination environment, no. Coordination engineering, I'm not finding much feedback from internet. I'm sorry to say that. Then we say coordination engineering of cobalt control over electromechanical. No, there's nothing as such. I can say coordination, accelerator coordination engineer. No, why no? I don't think people write something. Multi-agent system is objective coordination, multi-agent engine systems. No. Oh my God, I'm not able to find anything. This is a deficient work. It's a very deficient world. Technical coordination in engineering. So 2000, it's very old it is. Design engineering, problem and coordination. University of this, let us say, is about best of engineering team. I cannot find. I don't think there's something available. Is void in coordination. Coordination in construction industry. Let us see little of this if we got something, or BIM coordination we can see. Let's just take that. Let us then take up this. Maybe something got from this. This is 18 December 2020, 2 years back. I think effective design coordination, and this is here you can say coordination in construction industry. I think we have already gone through this. Well, let's say something. If you can, I can read it again for you. If you think it is good, otherwise there's no meaning at all. Let us see. Fox gives something again. It is designing buildings.co.uk, and let us say it helps us. If it can help us, we can get something. I'll close this page. No problem, because I do not waste time for nothing. You can see, and this is not doing well. I think it's coming. Yes, it's coming. It's coming, and I think I've taken this IC already. No issue. Coordination in construction industry. It says coordination in construction industries. We have to be serious about this issue. Only then we can understand. So, coordination in construction industry, coordination or coordination. There are first the process of organizing people, systems, activities, and so on and so forth. They work together. Coordination is generally considered to improve efficiency and effectiveness, whilst fragmentation can cause inefficiencies and even clashes. Coordination is a particular issue in construction industry where teams of people may come together to work on a complex design and construction. You can say complex design and construction involving many interrelated elements. When project is finished, they may disappear or disperse and might not work together again. Ensuring that this team works effectively together requires careful consideration, integration and collaboration. So, what it says requires coordination, integration and collaboration. Not something that industry is always successful at achieving. This means there exists void, big void. Let us see in construction industry, coordination in construction industry, coordination often refers to design coordination. In construction industry, coordination often refers to design coordination, that is, integration of designs prepared by different members of project team to create a single unified set of information that can be constructed without clashes between components. Effective design coordination can help to reduce costs. That's what I always stress on designs. Again I read, in construction industry, coordination often refers to design coordination, which is integration of designs prepared by different members of project team to create a single unified set of information that can be constructed without clashes between components. Effective design coordination can help to reduce costs, delays, and disruption that can be caused by problems on site and requirement for remedial or abortive works and redesign. Now, coordination in construction industry may also refer to BIM model coordination, spatial coordination, supply chain coordination, coordination of documentation or policies, coordination of construction activities, coordination between bodies such as government departments, collaborative practices between project team members, integration of systems such as transport, and we can say there may be many articles in this, and you can say BIM coordinator, information modeling, CDM coordinator, clash avoidance, collaborative practices, design coordination, design coordinator, design management, fragmentation, information manager, integrated design, lead designer, retrofit coordinator, tolerances, and likewise we can say, if we go further, there's nothing on page 2. Why? There's nothing on page 2. What's that? I'm not going to move further on this. What's the reason? Something wrong, I think, here. Let me see what's wrong. Well, I think there's no information. This was and of that. No problem. This was and of that. So there are projects shown on this. No problem. This is enough information we got from this. I like to close this page and find something else if I got here in. So if you go back to that website, it says here, let's see, I'm trying to find more information. That is BIM model coordinator, articles on coordination BIS model, and says BIM model is trying to say what's that. It's not difficult to understand. It is, project information model, and that is, I'll try to show that what other countries think about. Let us see. I'm being print. Other one is building information modeling, and of course it's something good one. But let us see how it works. Does give something information. You see, I'm trying to do something. I can get you more and more information, and that's the important one. Here you can say project information model, and that is, you can say, it is, of course, it says building information modeling, BIMS we usually call it. It's a very broad term that describes the process of creating and managing digital information about a built asset such as building, bridge, highway, tunnel, and so on. In UK government construction strategy published in May 2011 stated government require fully collaborative 3D BIM with all project and asset information, documentation and data being electronic as a minimum by 2016. This represents a minimum requirement of level 2 BIM on centrally procured public projects. Level 2 BIM is creation of a managed 3D environment. Level 2 BIM is creation of a managed 3D environment with data attached but created in separate distinct discipline models. Separate models may originate with client, architect, structural engineer, building services engineering contractor, subcontractors, suppliers, and so on. A federated model is an assembly of these distinct models to create a single complete model of building, developed and used through design, construction, operation, and decommissioning. Then we can say PS 1192 to 2013 specification for information management of capital delivery phase of construction projects using building information modeling specifies requirements for achieving building information modeling level 2, focusing especially on project delivery. Its application begins with a set statement of requirement and works through stages of information delivery cycle. It describes project information model as information model developed during design and construction phases of project. Requirement of project information model set out are set out in Employers Information Requirements (EIR), Employers Information Requirements at Level 2. It's likely to consist of a federated building information model, non-graphical data and associated documents. Project information model is developed progressively, first as a design intent model, then a virtual construction model. In early stages, design intent model is likely to include massive diagrams of or 2D symbols to represent generic element of designs with some critical elements developed in more details. Design progresses, it will develop and level of detail change increase, including first objects based on generic representations and then specific objects with the specifications and method statements attached along with information about space allocation for operation, access maintenance, installation, replacements, and so on. Design intent model is then developed into virtual construction model containing all objects to be manufactured, installed, or constructed. Ultimately, once construction is complete, project information model is developed into an asset information model, AIM, to be used during operational phases. Project information model should be developed in accordance with Master Information Development Policy, MIDP, and delivered to employer through a series of information exchanges, data drops typically comprising a series of federated building information models, including non-graphical data and associated documentation, comprising native and industry foundation classes, IFC files, construction operations, building information exchange files, and other structured data such as schedules, reports, and other documentation. These may be read only PDF, but native files can be more useful as their contents can be more easily interrogated, copied, and edited. This data exchanges affected key points in project development that coincide with the employer's decision-making processes as defined in employer's information request. Related articles, so what may be articles or articles. So I close this also. This has done its job. I'm not going to project information, and I'll take another glimpse up, we can say here. Let's go to, you can say here, and that is spatial coordination, supply chain coordination, coordination of documentation of policies. Let us say spatial coordination was that. Spatial coordination is also, let us understand what is that. Spatial coordination, process of completing and design of construction of building is often, that's what they say. Let us print this out also. I'm just trying to give you as much as possible, and also it benefits me, you know. It's not just my benefit, to everybody's benefit. It's maybe 1 page or 2 pages, doesn't matter, but at least we know what's included in that. It's from, you can designing building sites, so it's better to know something about that. What it says is this, you know, it is, you know, you can say, let's see, it says about, it says spatial coordination, and this also recent one, 2021, and here is recently, we can say process, this is spatial coordination process for completing design and construction of a building. Process for completing design and construction of a building is often divided into stages, and this can be helpful in establishing milestones for submission of progress reports, preparation of information for approval, client's gateway, and for making payments. However, there is a great deal of ambiguity between, there's a great deal of ambiguity between naming of stages by different organizations and definitions of what individual stages actually include. And it is important that appointment document make it clear specifically what activities fall within which stage and what levels of detail is required. Spatial coordination is a new stage introduced by RIBA Plan of Work 2020. This replaces developed design in 2013. So developed design is gone and spatial coordination comes into picture. Okay, detailed design, developed design. Detailed design is spatial coordination now. And RIBA plan of work is published by Royal Institute of British Architects, is split into number of key projects stages. RIBA plan of work provides a shared framework for designs and construction that offers both a process map and management tool. So in 2013 edition is a comparison here. It was strategic definition, and here is strategic definition 2020. And here is, in 2013, preparation and brief and preparation briefing. Means brief is briefing. Concept design is concept design. Developed design is spatial coordination. Developed design is spatial coordination. We have space and we have to code accordingly. Technical design is technical design. Construction is manufacturing and construction. So construction is gone to manufacturing and construction. Handover and closeout is handover. And use is use. This is what is changed. Not big change, I think. It's not big one. 2020 edition plan of work suggests that spatial coordination stage is fundamentally about testing and validating architectural concept to make sure that architectural and engineering information prepared at stage 2 is spatially coordinated before detailed information required to manufacture and construct building is produced at Stage 4, Stage 3 is not about adjusting architectural controls, concept which should remain substantially unaltered. Although detailed design or engineering tasks may require adjustments to make sure that building is spatially coordinated, it suggests that a spatially coordinated design is a design in which clients' spatial requirements and space is required for whatever building systems, such as structural and building services, engineering aspects including grids, risers and plant rooms have been determined and fixed to allow stage 4 to progress without any further iteration. And I think we have to go to next one because this again articles here, and we can say if you go back, I'm just trying to give as much information as possible. Again I say, so this spatial coordination, and let us see what actually is. His test is different. Let's go to spatial coordination. What says it's not even so. It's not any link here, unfortunately. So we can't say anything about this. RIBA plan of Fox, architectural concept, spatial coordination. I'm trying to find building is spatially coordinated. Let us see what is that. Spatially coordinated here, if I can get some information here, and it is spatially coordinated. This means something. It's the same thing, nothing much different, so I just want to waste time on this, a little bit behind. I had gone this, let's say, spatially building information modeling. Building information modeling, let us see. Building is famous, modeling will start, building information modeling, that is here, and building information modeling, let me take print out of this if you can do. Let a minute please, just wait a minute. Come on, print out, come on, don't waste time. Okay, say. Here's building information modeling. You can say head 0, 1, 2, 3, 4, 5, 6, likewise 7. 7 is showing size, saying 7 stages, and there's a definition. 1 is definition. Here is definition 1, and then 2 is policy. So this definition policy. And 3 is uptake, so definition, policy, uptake, and 4 is characteristics of BIM, so this is characteristics of BIM, and 5 is software, and 6 is 6 is protocols, standards, and tools, and 7 is related articles. All right, so this is a building information model, and we have to see that one. How does it speak? Building information modeling is a very broad term that describes process of creating and managing digital information about building built assets such as building, bridge, highway. We have gone through this already. ISO 19650-201 defines BIM as use of a shared digital representation of a built asset to facilitate design, construction, operation processes to form a reliable basis for decisions, transforming infrastructure performance. And roadmap to 2030, published by Infrastructure and Project Authority 13 September 2021, defines BIM as a combination of process, standards, and technology through which it's possible to generate, visualize, exchange, assure, and subsequently use and reuse information, including data, to form a trustworthy foundation for decision making to benefit of all those involved in whatever part of assets life cycle. This includes inception, capital phase, procurement and delivery, asset and facility management, maintenance, refurbishment, and ultimately an asset's disposal or reuse. Course inclusions are inception, capital phase, procurement and delivery, assets and facility management, maintenance, refurbishment, and ultimately and assets disposal or reuse. Policy. In UK government construction strategy published in May 2011, stated government will require fully collaborative 3D BIM with all projects and asset information, documentation and data being electronic as a minimum by 2016. This represented a minimum requirement for level 2 BIM on centrally procured public projects and applications. While level 0 is represented unmanaged CAD computer-aided design, that is level 0 represented unmanaged. Level 1 is represented managed CAD in 2D and 3D. Level 2 is represented managed 3D environment with data attached but created in separate discipline models. And level 3 is a represented single online project model with construction sequencing, cost and life cycle management information. So 0, 1, 2, 3 here are represented unmanaged 0, and 1 is represented managed 2D and 3D, and level 2 represented managed 3D environment with data attached but created in separate discipline. And level 3 is represented single online project model with construction sequencing, cost and life cycle. Now BIM level 2 was superseded in UK in 2018, so represent managed 3D environment with data attached but created in separate. This was suppressed. UK BIM framework sets out overreaching approach to implementing BIM in UK. It was developed jointly by UK BIM Alliance, BSI and Centre of Digital But. Well, UK BIM framework published is all like update. Now NBS has suggested that adopting BIM can cost a price 10,000 sterlings per workstation. National, okay. However, this depends on whether implementation is simply an exercise in buying hardware and software and then training staff to use it, or whether it's a part of wider process of business change. Now, justification for this cost in value that adopting BIM brings to a project throughout life cycle. BIM task group states suggest that if successfully implemented, help organizations step waste from their processes, which in many cases could be bandwidth limited. Now, I don't think this is our. So, characteristics of BIM. Fundamentally, BIM is to ensure that appropriate information is created in a suitable format at right time, so that better decisions can be made throughout design, construction and operation of built assets. It is different, what says better decisions can be made through design, construction, operation of built assets. It's not about creating 3D model for its own sake, and it's not an add-on process. BIM is fundamentally way a project is set up and run. BIM centers around creation of employees and information requirements, which define information that employer wishes to procure in order to develop and operate a built asset. Setting this out in contract documents ensures that appropriate information is created in a suitable format at right time. So it is, you can say, a very broadly building information that might be required is categorized as 2D, 3D, 4D, 4D including time, program information, and 5D is including cost information, and 6D is including facilities management information. For more information, our level 2 building information model are likely to comprise a series of federated models prepared by different design teams, including model files, documents, and structured data files containing non-geometric information about facility, floors, spaces, systems, and components. Together, this creates a digital replica of built assets that starts by representing design intent. But handover reflects what has actually been built and installed, and the creation of a geometric model as part of this process allows buildings to be conceived collaboratively and tested virtually before they are built and operated for real. This should reduce problems that are encountered in construction occupation. And also these models are created from a series of parametric objects. Each object is defined only once and then placed in model in multiple locations as required. If object is then changed, these changes will appear throughout the model. This makes model automatically consistent and reduces errors. And a common data environment is single source of information for project used to collect, manage, and disseminate documentation, graphic model, and non-graphic data for whole project team. Creating this single source of information facilitates collaboration between project team members and helps avoid duplication and mistakes. So, according to National BIM report, most popular drawings tools are Autodesk, Revit, there's also protocol standards and tools. I think we have done what we got from this is fine, we'll go back to other one. Not to waste time for nothing. If you get some information, it's fine. I'm just doing live it is, and you cannot waste time like that. We have to be very realistic in this. Let's go to some other information which is after. And here's BIM. Now CDM. Let us say what is BIM coordinator. Let's see what is that. What does the BIM coordinator about? Is it useful or not? And BIM coordinator, let us see. It's long, but it's not, I think, not much have. Let us see what it says, or I'll immediately close it. Let us see what it says. I'm just trying to see, means it's updated, and I'm finding in many places. BIM, but what it is actually, I wanted to see and share with you the live, and therefore you have to bear, because I did not study before, but we are just collaborating study during live session. So BIM, Building Information Model, a broad term that describes process of creating and managing the whole library as an integrated data-led process enabling team to manage information of the project, coordination of building information model parts of it's an important responsibility. BIM coordinators can therefore be key members of project team, helping establish and manage BIM project workflows and assisting in effective resolution of issues that arise. However, standards that establish level 2 BIM do not refer to role BIM coordinator. This is partly because they are written form of perspective of government as construction client. So what is a manage only with hand? What it says, information manager, refer to an information manager as a procedural gatekeeper, policing common data environment and ensure that it follows agreed protocols and that data is secure. However, this information manager has no design responsibility, then leave it. As a result, the term BIM coordinator is a relatively ambiguous one, which may refer to coordinator or several coordinators within a project or organization whose responsibilities could include developing what responsibility maybe. Let us see. Developing and maintaining BIM protocols and BIM execution plans and other documentation, ensuring protocols are adhered to, managing data sets, coordinating stakeholders in terms of their role within BIM process, ensuring accuracy of models and data sheets by establishing quality control procedures, clash detection and clash avoidance, preparing BIM coordination programs and progress reports, providing training and assistance to project team, and explaining procedures and standards, sourcing and maintaining model contents, where there are shared data and inter-model relationship, making sure these are recorded and monitored, coordinating data modeling and management, liaising with design team and client, coordinating handover of information at project milestone. We repeat it, it's something important, I think, and it is, we can say, developing and maintaining, you can say coordinator it is, rather than what we said, BIM, etc. It's same thing as coordinator does. Developing and maintaining protocols and execution plans and other documentation, ensuring protocols are adhered to, managing data sets, coordinating stakeholders in terms of their role with BIM process, ensuring accuracy of models and data sets by establishing quality control procedures, clash detection and clash avoidance, clash detection and clash or conflicts, you can say, preparing coordination programs and progress reports, providing training and assistance to project team, and explaining procedures and standards, sourcing and maintaining model content, where there are shared data, intermodal relationship, making sure these are recorded and monitored, coordinating data modeling and management, liaising with design team and client, coordinating handover of information at project milestones. Well, I think this is what we could get from here, and it's of course not very bad. Something is always good. So we can say that it is sometimes good if we take better control of that. Nothing wrong with anything as such, you can say. So we go back to other one if we got something, or we close. This was useful, so I'll add to my own point. Then clash avoidance, this is another one. CDM coordinator, what is that? Let us see CDM coordinator. CDM coordinator, it says articles are there. This is CDM coordinator. This is for 15. CDM coordinator, principal design, principal coordinator. Principal designer is responsible for pre-construction phase, while principal contractor is responsible for construction phase. Just regarding this, I don't think there's something very important in this CDM coordinator. CDM coordinator was substantially, these are very solutions saw role of CDM coordinator, transfer to principal designer. I'll leave it as not very basically. I don't want to discuss. Very basically, I don't want to discuss here. I want to discuss design coordination. Let us say design coordination. What does it say? It may be better for everybody. Let us say it is about, I'll take print out of this, is better. Print out of this is required, print, and I'll take it. Design coordination I'm talking, which is of use for everybody. It will help us, maybe it is certain design coordination, maybe one page, not more. I'm trying to import something which is good for us. It is 23rd September 20, and just few pages, 1 or 2 pages more, say not more than that. So we can bear with this design coordination. can say design coordination. Design is the process of creating a solution. Design is process of creating a solution to a project brief and then preparing instructions, allowing that solution to be constructed. Building design is typically a multidisciplinary process involving a number of different designers, such as architects, engineers, and so on, working together to create a single holistic solution. Problem can occur where there is missing information, poorly communicated information, inconsistencies between documentation, poor resource allocation, poor decision making due to inadequate information, and so on. These difficulties have become more prevalent as buildings have become more technical. Range of products and materials has increased. Standards and regulations have become stricter. And there are a greater number of specialist designers. Design coordination is a broad term describing integration of designs. Design coordination is a broad term describing integration of designs prepared by different members of project team to create a single unified set of information that can be constructed without clashes between components. Effective design coordination can help to reduce costs, delays, and disruption that can be caused by many problems on site and need for removal for remedial or absorptive works or designs. In its broader sense, design coordination can simply mean ensuring that designers understand what they are responsible for, and in particular who is responsible for interfaces and junctions between different design packages. In a more specific sense, design coordination can refer to actual process of ensuring that design solutions can be integrated in particular mechanical, electrical, and plumbing designs, which as they permeate through entire building are frequently source of coordination problems. This is particularly true for complex buildings such as hospitals, where there may be a great number of building services that require to be installed in relatively confined spaces. Clashes may be hard clashes. Clashes may be hard clashes, for example, where root for pipe work runs through a steel beam. They may also be soft clashes, which can be a result of construction tolerances, too little space to install or maintain a component of building, lack of consideration of health and safety requirements, too many workers being programmed to carry out works in same space at same time, and so on. There are a number of procedures that can be adopted and appointments made to help minimize clashes and ensure proper coordination. Typically, where there is a multidisciplinary design team, a lead engineer, a lead designer appointed whose role includes integrating different aspects of design and their interfaces into overall design. Amongst other things, this may involve ensuring collaborative practices are adopted, coordinating quality control system, adopting standard methods and procedures, coordinating preparation and issue of production information to contractors and suppliers, reviewing designs prepared by contractors and suppliers. For more information, we have to see somewhere else. Process of actually verifying design coordination still sometimes relies on manual techniques for cross-checking information with transparent design drawing overlaid to identify potential conflicts. Computer-aided design can replicate this process on screens, allowing drawings prepared by different designers to be compared. Building information modeling involves creating and managing digital information for designs, construction, and operating built assets. BIM can help ensure the collaborative practices are adopted and standard methods and procedures used, and designers are contractually obliged to provide specific information at the specific stages of a project. One of the benefits of adopting BIM is potential for better avoidance of clashes that can help ensure There is spatial coordination between different components. However, BIM Level 2 allows designers to work on separate federated models that are only brought together to create a single complete model of building case cases. This building information model may also be broken down volumes to allow more than one person to work on project code assemblies. Clashes avoidance, clash detection must therefore be carried out as an integral part of BIM process. From defining standard methods and procedures and establishing a BIM volume strategy through spatial designs and creation of a virtual construction model, and should continue during construction phase itself as a model and updated. Clashes detection software from this about, and it can be used for our work, and I think we can get benefit of that. Something is better, and we can say something is always better, and that's what we are here. And let us say if we can get some information on this. um, I just copy it for incorporation into my file. It's better to do something like that. So no issue. No, I go back to other types that you are doing in designs, design coordination, design coordinator, design management, fragmentation, information. I leave it. I am not interested in that. It's enough food we have got from this, and that's what I say. Sometimes better, sometimes not better. So I can say that here is now this I was talking, and now I'm taking back to file. That is important. That is about coordination and coordination engineering. We'll discuss this now because we have got enough food from our we can say we got enough food. Just give me 5 minutes. Let me just 5 minutes, please. I'll be here back. You meanwhile, I take some water, and that's coordination, we've gone through some labs, we've gone through the IMS, and that is, BIMS, and also in past we are interested in BMS. You're now in coordination engineering back, and we really understand what should be done, what should not be done. It's a very important one. And we have to realize this fact, and not otherwise we will be in problem. We will not be able to understand what to do, and therefore we have this issue that's causing something. Coordination is not that actually what we think is everywhere. It should be clearly understood. Only then we can get something out of that. Otherwise, it's not that what we may say and what we may not say. As in fact, we can say something is very specific, and it's not simply specific but very important. The point we have to understand. Coordination is not that easy as we think it is. It is very interesting as well, as if you understand, because we can start. It's always deliberated in a way. It should be or should not be. We can adopt ourselves to that situation, and also a brief I can give it there, but it happens or doesn't happen, that's different. It's all same, we can say. All right, we continue our talk. We continue our talk on coordination, and it is really important one. Let us as we try to say, coordination engineering is a must on every project. It's nothing new. It's nothing new. You know all. There's nothing new in this. As I said, in deliberation, minute deliberation, we studied, and coordination is not clearly understood. This also we said that coordination is not clearly understood. There is no doubt in that. Without adequate coordination, works cannot be done efficiently. That's also true. And if we do not do that, in professional engineering, we cannot call it professional engineering, because works cannot be successfully accomplished without coordination. Coordination is not clearly understood. It's very true. And the fact remains that without adequate and efficient coordination, professional engineering works cannot be successfully accomplished. That is also true. What we have to decide on this is that what is coordination, how it is done. We have gone through that system requirement and we are deliberating it again and again. It is difficult, of course, and I say coordination is not clearly understood by many professions. Others in this right required spirit. Fact remains that without adequate and efficient coordination, professional engineering work cannot be carried out successfully. And if I could claim, it shall be right to admit that coordination failure leads to engineering design and construction failure. That's also true, because designs and constructions are same family. Without construction, design doesn't succeed, and without engineering designs, construction cannot be affected. That's true. What shall we do if there's no design? How can you construct? And how can you claim construction is okay if there is no construction? For many engineers, we can say, or let's just like it's okay. For many engineers, issue of coordination remains very delicate, and such engineers try to avoid involving in coordination complexity and just expect someone else should give final working drawings for work executions. Even if we have software, BIM as we usually call it, in my software, we may not be able to do that because software is software. Best software is human being and our personal efforts, we can say that. What I can do myself or you can do yourself, involving personal attention, personal efforts, there is no equal to that. In fact, I have experienced engineers from around the whole world. They just want to run away from scenario of coordination. You can say, I have experienced that engineers from around the whole world scenario. A majority engineers population do not have any interest in working on coordination activities due to essential requirements on concentration, on concentrating or focusing constantly on engineering and in-depth technical issues involved. And it's a very, very difficult concentration, and you can say dipping yourself, immersing yourself in that world. Immersion of mind is required. Immersion of presence is required. And problems are not counted in numbers, but in considering gravity of situation, complexity and strong decision making related to whatever work items are involved. Coordination definition is for sure necessary to be understood for its real meaning so that no mixing results in. Coordination is gross, it is subjective, it is disciplinary, and it is minute, or we can say at detailed levels. Mixing means a state of confusion which should be avoided. A state of confusion meaning indicates that right activity related to work cannot be carried out at right time, and that you can say nothing can be done in that case. If right activity is not carried right time, either work is done incorrect or it is delayed until that information is received and applied or included or provided. In construction world, in particularly structural and buildings, constructions, no limitation of drawings and detailings exist. No numbers can be given. It depends on requirements. Unknown numbers, unknown requirements, but real one. In construction world, in particularly structural and buildings, constructions, no limitation of drawings and detailing prevails. Even for a small building or structure, categories of drawings and detail remain same as if it could be a mess-up building. Now, it depends on designing professionals about how to apply drawings and detailings so that construction personnel should not refer back all times, every time, for either information, either confirmation or clarification of various issues involved. Coordination can therefore be defined in that way all branches of engineering, all branches of engineering involved, and all disciplines involved in ongoing activity must be clearly described and detailed so that no information is left out that could hold progress on activity or path of whatever activity. If even one small information is held without having adequate details or is not formally confirmed, activity can stop or it shall be carried out based on either correct or incorrect knowledge possessed by site team, which work could be considered in contravention of what designing team contemplated. Consequently, it shall be certainly leading to cause formal errors. It also remains the fact that no subject or no branches of coordination engineering is available for imparting professional education at any either diploma or degree level, and even if it may be considered up to top doctorate level. Absence of inclusion of this very significant subject within engineering program explicitly indicates and evidences that education professionals do not understand value of engineering coordination discipline and have gone through searching many sites on internet about coordination in engineering, and I'm disappointed that I could not find many informative notings or chapters, very few, and that to theoretical type, not practical type. Moreover, it cannot be called educationist's fault. I don't limit to that, because they do not remain active field of engineering profession and therefore not subject to attaining practical field professional experience. And we should know that practical field professional experience is solution to good construction and good successful design. Coordination engineering is an unlimited world and it can expand its vistas to unlimited areas involving many disciplines in one branch of engineering and also importing various branches of engineering depending on what class of works are affected. We have also seen an era of coordination past when there used to be no electronics related technologies, and we call it information technology, that one, but wherein large voluminous works were carried out on civil, electrical, mechanical and architectural engineering disciplines. Even if that era work of coordination was done very much time consuming, of course, due to fact that drawings used to be manually drafted or drawn and all activities were carried out accordingly, calculations were done manually and all bar charts and whatever we used to do or writing was done manually. Coordination engineer would have been appointed had incumbent professional been experienced on considerable size sites, and whosoever professional having just one engineering discipline knowledge could not be successful for efficient working on site and progress, consequently either marred or errors caused, and therefore it is very heavy position on site because coordination is required, determination is required, devotion is required, hard work is required, intellectual is required, and whatever else you can say, no timings. Such unhelpful situations force professional engineers to work long hours to have firm grip of design details and correlated one discipline with other disciplines one by one, of course, consuming considerable work allotted time. An understanding of coordination definition and respective description makes certain differences on works. We may not call it teamwork for sure, because coordination cannot be done effectively by team, but certainly by perfect getting through all related details available on schematic design as well as on other documents. And of course, professional market prevailing conventions are so-called good industrial practice. And of course, members of project team are required to extend engineering support to engineering coordinator, without whose input no coordination activity would move. Whereas engineering professional involved on every coordination has to involve personally on every provided information or for purpose of corroborative ratification based on total scrutiny as well as necessary examination or investigation of all details. Coordination is a never ending activity which therefore cannot be considered a time fixed activity. It depends on design mandate and scope requirement along with other contact documents such as engineering design specifications and required input from special material producing manufacturers such as documented instructions and material data studies. Complexities of technicalities and the structure of resources have certainly created additional complexities when many disciplines or branches of engineering works together, forcing attention from coordinating professional to look into all requirements, contract related and industry related as well as codes mandate related. In fact, coordination at higher level of responsibility is always a voluminous task which work imports working knowledge of various engineering branches and additional in-depth knowledge of one's own engineering discipline. It's also true that in current engineering or advanced project scenario, just depending on certain proclaimed software may not be absolutely assistive to automatically resolve details pertinent various conflicts among various disciplines, and therefore no blind eyes can be allowed to thrust the outcome of various conflicting details into physically workable solutions. As many times on various components of whatever project to invite equivalent additional or augmentative levels of coordination for all such designs and respective detailing applications on site work. Site work depend on finally agreed details which we sometimes name or entitle current documents under proposal and then approval as such working drawings and also shop drawing and finals to cover all disciplines in a unified approach coordination drawings. Such activities to produce coordination drawings on various areas of project components do cause professional requirements from various disciplines. We can say require professional input from various disciplines, and where coordinator has to apply mind fully immersed in an imaginative contemporary ocean of details, keeping abreast applicable specifications and contract related documents, and of course contractual complexities that make entire situation little more complex. And in certain cases, a major overhaul requires to be effected. It is really disappointing to note that our coordination preference has been found missing among engineers at beginning of professional career. When one tries to or opts to specialize just on its own discipline, even discarding its own branch relative other subjects, it's of course necessary for professionals to be for sure attain at some specialization, at some specialization level, but simultaneously must move on parallel tracks with remaining disciplines and certainly try to join other engineering branches overlapping. Here in this stage of conferring, I like to infer with entitled terms such as specialist engineers, organizers, managers, as well as others. Because it is question of coordination, and coordination means It's about detailed work. It talks to every detail, it talks to every overlap, it talks to every relative activity, and because one has to understand at least the shape or this title or at least ask for further details, because cognitor is not really supposed to involve in complete details but connecting details, we can say, just like it has been said, interfaces or inter information approvals, you may say. We understand what is compatibility requirement between two equipment, and we have to know about that. Whether these two agree, if these two specifically agree, in that case coordinator also agrees. Coordinator is not a competent authority there as far as technical details are concerned or compatibility is concerned, but it should be compatible to make sure that is coordination job, depending on feedback given by those specialists, electromechanical engineers. So that's what we have to say is just one example. And it's also admissible that every professional engineer must have associated certain ambition to to reach certain goal in professional world. But this doesn't mean that such professionals shall have to leave all other aspects that apply within profession for cohesive working. And cohesive working means integrated working, means working in the same environment. Well, adhesive working starts when you come into contact with other professionals, and this means cohesive working and cohesive plus cohesive plus cohesive working, and then adhesive plus adhesive plus adhesive. Both kinds of working would be available, would be required. Cohesive working in your own profession or own disciplines, whereas other disciplines come into check, you can say, such as electromechanical or someone else out of one profession. That case, collection of this can be called, you may say, cohesive working, and then adhesive working, and then mixing working likewise for overlap purpose. Focus not find any final stop, no final stop or no period, you can say, but continuation of specialization and then additional working specialization as major requirements in engineering profession. Because engineering cannot be replaced or overtaken by any other non-engineering professional, one should consider possibility that organization management can be replaced by professional engineer. It is positive criteria, whereas vice versa doesn't apply, howsoever seriously one may try. I mean to say that when the person is qualified as an engineer, that person knows specifically about engineering issues, and that person can understand, after having some experience, pluses and minuses or actions or no actions, what can be good or bad results. But that criteria one can understand because one is particularly educated, particularly trained for that purpose, but doesn't apply to those who are non-engineering professionals, who are non-engineering personnel, and if they are allowed to work in this field on sites or else, it may not work well. It's for sure. So we have to keep in mind that management doesn't mean non-engineers in engineering world. Management means it is engineering management, it is engineers, and not others who have no engineering background, and that can cause a problem. It's not name of degree you have, it is power of degree you have. Engineering degrees are very powerful in engineering world, in development world. We cannot just erode its power. All those so-called proclaimed managers who try to dominate engineering professionals or project managing organizers have never succeeded without having total reliance on responsible professional engineers for engineering details applicable on Projects cannot be learned just by going through certain baseless curriculum involving no engineering subjects. So why we say one should consider positively that management organization can be replaced by professional engineer, whereas its vice versa does not apply, howsoever seriously one may try because of lack of engineering input in details. And that is very big question mark here. So what we say, again we come back to coordination. Coordination engineering amounts to such physically invisible fundamental domain which requires perfect detailed engineering knowledge and thorough knowledge of specialized practical experience, or else no professional can get work delivered successfully and qualitatively. Qualitatively minded is very important point here written. No work can be completed in modernized project without using impetus from coordination engineering. And in fact, coordination engineering is complete connection among all branches of engineering that can be said. Coordination engineering or overlapping engineering or interconnecting engineering. Coordination is title which give to that because nobody is inferior or nobody is superior in coordination. When we are involved coordinatively, we are in the coordination style, everybody is equal, but we have to move in one car, all. One vehicle, coordinate engineering means vehicle moves there, taking all stakeholders together, technical stakeholders. So no work can be completed in modernized project without using impetus from coordination engineering, which is a combination of all involved prime domains. And this point we have to understand very clearly what we are talking about. Best suited for such type of professional interactive engineering are all those experienced professional engineering organizers who have invested their practice on every such activity in addition to having attained positive, respective expertise. In fact, currently coordination is like a super domain, or you can say a domain which doesn't measure its name. It doesn't depend on but coordination. Coordination itself is also required. In fact, currently coordination is like a super domain for which an ordinary educated engineer cannot best suit in or fit in. But if one has got multi-level experience in office engineering as well as site engineering, can perform such tasks efficiently provided involvement is made, concentration is affected, and will required, because this is very serious discipline, very serious. To be very frank, in stating definition of coordination in a nutshell, it can be acceptable to describe an engineer who can procure all related professionals belonging respective individual disciplines onto a firm and final agreement on whatever involved project component or components and whatever activity applicable on a set of combination of all architectural, structural and services drawings, free from every clash or conflict, or it may be named coordinated drawing for all practical working purposes. Coordinated services drawing, or whatever you want to use, coordinated services drawings, architectural, structural coordination drawing. Likewise, there is no limit. I just indicative, I have given indication. Now it is what I said, whichever activity applicable on a set of combinations of all architectural, structural, services drawings, free from every clash, or it may be named coordination drawing for all practical working purposes. It's not very specific that